This video will cover the Geometry Common Core exam from June 2015, questions 26 through 28. Question 26 says the diagram below shows parallelogram LMNO with diagonal LN. Measure of angle M equals 118 and measure of angle LNO is equal to 22. Both of those degree measures are already labeled in the diagram. And our goal here is to explain why the measure of angle NLO is equal to 40 degrees. NLO is this angle right here. So let's call that x. We're going to actually solve for x and then justify and explain why it should be equal to 40 degrees. So hopefully our work will get us to the point where we find that it's 40 degrees. Now we have a little bit of information in the beginning that will help us figure out how to find x. LMNO is a parallelogram, which has two pairs of opposite sides that are parallel. So that tells me that ML is parallel to NO. And if we have parallel lines, our first step is to look for a Z, whether it's a forward-facing Z or a backward-facing Z. Z's help us to find alternate interior angles. So looking at this diagram using the two pairs of the two parallel sides that I just talked about, I find a backward Z. So if angle LNO is 22, then angle MLN should also be 22. And I'm actually going to explain as we mark up our picture. So I'll first say that the measure of angle MLN is equal to 22 degrees because parallel lines form congruent alternate interior angles. Next, I'm going to look at the diagram and see that I also have another pair of parallel sides. LO is parallel to MN. Parallel, parallel. I should get double parallel here because I already used a single parallel. So now I'm going to again find a Z using this transversal. So here it shows me that angle NLO is congruent to angle LNM. So I'm going to call this piece X also. So now it looks as though I have a triangle with 22, X, and 118. So let's take a second to find X. 22 plus 118 plus X equals 180. Remember that three angles in a triangle sum to 180. 22 and 118 give you 140 plus X equals 180. Subtract 140 from both sides, so we end up with 40. Look at that. We get 40 here, where this X is, and because those angles are congruent, that's 40. But we're not ready to explain why NLO is 40 just yet. We have to talk about the measure of angle MNL, which is also 40. And this was because three angles in a triangle sum to 180. Then we can talk about the measure of angle NLO equals 40 because parallel lines form congruent alternate interior angles. Again, we found that Z there in yellow. Number 28 says the diagram below shows a ramp connecting the ground to a loading platform 4.5 feet above the ground. The ramp measures 11.75 feet from the ground to the top of the loading platform. Determine and state to the nearest degree the angle of elevation. This means to look up. Formed by the ramp and the ground. So our goal is to find the angle formed between the ramp and the ground. So I'm going to choose to call this theta. If you don't like theta, it just means an angle measure. You can call it x. X is fine. So here it looks like we have two sides and one angle. So that tells me that I should be using SOHCAHTOA, my sine, cosine, or tangent. SOHCAHTOA. Where S means sine, C means cosine, T means tangent, O means opposite, A means adjacent, and H means hypotenuse. If I look at my theta and I circle it and start to label my sides as H's, O's, and A's, I end up seeing that all the way opposite of the angle of theta is O, opposite. And this big, huge side, 11.75, is the hypotenuse because it's across from the right angle. So O and H force me to use sine. So now I'm going to fill in my equation. Sine of the angle, which happens to be theta, again, if you don't like theta, use x, equals opposite 4.5 over hypotenuse 11.75. So now here, because I'm trying to find this theta, I need to pull theta on the outside of my sine function. So I'm going to say theta equals sine, but it's not a regular sine anymore. It's actually sine inverse. That's what that little raised to the -1 means. Sine inverse. So now I have sine inverse of 4.5 over 11.75. And this is actually something that we can just type in on the calculator. Use calc. If you have a TI 83 or 84, you need to make sure that your mode is in degrees. So hit the mode button and then hit degree and hit enter. If you have a calculator that's a TI Inspire, you're good to go. It's already in degree mode. So when I type in sine inverse of 4.5 divided by 11.75, all inside of the parentheses, I end up with theta equals 22.5183 blah blah blah. Keeps going. But I'm asked to round to the nearest degree. So that means theta equals, now nearest degree means a whole number, so I can't have any decimals, not 22.5, not 22.52, not 22.518, I have to have a whole number. So this 22.5 should get rounded up to 23 degrees. So that angle of elevation is 23 degrees.